So those of you watching this video won't get the sensory perception, but this is an example of a commercially available supersaturated solution. And those of you in the room have already found the little disc and clicked it. And you see what happens is that when I disturb that solution, it immediately precipitates all of the material. And what you can't see is it gets really hot because of the heat of crystallization. So this is a commercially available device. They cost about $6, and it's just called the Heat Solution. It's a reusable hand warmer, and you feel this now, and it's kind of squishy and flexible. I can really bend it, but as it cools down and it sits for a couple of hours, it gets really hard, like a brick of salt, like a salt block or something. And then to regenerate these, you have to boil them. You put them in water, boil them for probably 30 minutes or so, and then you have to be really careful with them. When you take them out of the hot water, you have to carefully transfer them. When I do this at home, I just set them on a towel and let them sit there and try not to disturb them. This is a problem if you have children in your house, because they can't control themselves, and they'll come up and grab one. Oh, sorry, there, I didn't give everybody one. So a really nice example of some chemistry in everyday life. So now, if we look at some questions to sort of reinforce this learning, what are the possible types of solutions? This says there's 9. What are they? You have 3 phases of matter: gas, liquid, and solid. So what kinds of solutions can we have? Gas, 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 liquid, gas, solid, right? Solid, 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 liquid, 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 solid, liquid, gas, right? So those are the kinds of solutions we can have. How about number 2? Think about your can of soda pop, the Diet Coke I've been drinking to excess lately. When the can is under pressure, when it's sealed, and then I open it, what happens? What do you hear? Right? You hear that gas release? So, is there more carbon dioxide dissolved when it's under high pressure or under low pressure when I open the can? Under high pressure, right? It goes back to what we talked about with the divers. The higher the pressure, the more gas dissolves. As soon as you open the can and you now have that can at atmospheric pressure, then some of the gas dissolves. Now, I didn't bring a Diet Coke with me today for demonstration because I'm trying to reduce my consumption to 1 20-ounce bottle a day, and I already chugged that at 6:30 this morning. So I'm trying to get down on the caffeine and sodium a little bit. But think about this. You've all seen this happen. When you twist open that can or that bottle of Diet Coke, and it's a colorless, clear bottle, what do you notice if you look at it? What do you see happening with bubbles as soon as you release that pressure? You hear the pressure releasing that was above there, but then if you look at the can or look through the bottle, you'll see tiny little bubbles coming out where it's actually degassing. So it starts going flat right away. So less pressure. And what about how much dissolved oxygen is there when you're down deep versus at the surface? Where is there more? At the surface or down deep in the water? Deep, because there's more pressure. So, on a warm day, really warm day in a pond, okay, we're not talking about Lake Superior, we're talking about a pond, a small inland water area. Where will the fish hang out in July? Will they be swimming up at the surface so you can spearfish them, or are they going to be down deep in the pond? They're going to go down deep because, why? There's more oxygen down there. Yeah, maybe it's cool. I don't know. Do fish like to be cool? I don't know. But I know fish like to breathe. Right? Because, you take them out of the water and they're like, right? Oh, they are. They are. Okay. So that first stuff was kind of an overview about definitions, how solutions form, why solutions form. Now we're going to talk about concentrations of solutions expressed mathematically different ways with different concentration units. The first concentration unit is mass percent. And we think of this as calculating it by the mass of the solute, what is dissolved, divided by the mass of solution, and the solution contains the solute plus the solvent, or you can think of it as the total mass, times 100. And that's how we calculate it. But we can also think of percent as a two-part unit that can be used as a conversion factor. And we think of it as grams of solute per 100 grams of solution. So we can use this as a conversion factor to do our fence post sort of calculations we've been doing all along in chemistry. So let's look at an example. How many grams of glucose are in 250 grams of a 30% glucose solution? Now, some of you might solve this by just saying, well, 30% is 0.3, and I'm going to multiply that by 250, and you'd get the right answer, okay? Because that's the kind of percentage math you've done before. But I'm going to show you a systematic way to do it in chemistry where you can then do it in a much longer fence post if that is what we need. We can think of 30% meaning 30.0 grams of glucose per 100 grams of solution. So we have a two-part unit that we can use as a conversion factor. Now the question's asking, how many grams of glucose do I have? So I started my fence post the way I've showed you. You always start with what you want and you'll never end up upside down. I started with my grams of glucose on the top per 100 grams of solution. Now to get my answer in grams of glucose, I have to get rid of grams of solution. So I multiply by the 250 grams of solution. Grams of solution cancels. I have the unit I want. And I have 75 grams of glucose. Now, here's the thinking part. How many grams of water are in that solution? How can you figure this out? There's a couple of ways. What's the most obvious, quick and dirty way to figure out if I have 250 grams of solution and 75 grams is glucose, how much water do I have? Subtract, right? So this is the quickest way. 250 grams of solution minus 75 grams of glucose is equal to 175 grams of water. Now, the other way that you can think about these problems is, if it's 30% glucose, how much water's in there? 70%, because remember, percent always adds up to 100. So we could have said, well, it's 70 grams of water for every 100 grams of solution times 250 grams, and we'd get the same answer. We still get that 175 grams of water. Okay, so now here's one for you to try. Go ahead and do this with your groups on the boards.